Alrighty, so we are looking at lesson 8.4, which is trinomial factoring. We've done GCF factoring, we have done difference of perfect squares factoring, and this is kind of the real deal, right? GCF is always kind of going to be used as like a first cleaning up thing. Difference of perfect squares, you hope that you get it, because then it's just like, oh, perfect square, plus minus, we're done. This is really where this is what factoring is, this lesson. So we're going to factor quadratic trinomials. By the way, a trinomial just means it has three terms, right? We're going to be looking at here like 1, 2, 3 terms. Go away. Oh no, why is it loading? Okay. What is this thing doing? Whatever. So we're going to factor quadratic trinomials through identifying and analyzing the patterns in factors, and we'll see like what we're doing in a minute. First though, I actually kind of like this do now. So I'm just going to do it. It's a good practice problem, even though it's kind of unrelated. It's just like, you know, it's good to do. So given that f of x is 2x plus 1. So I'm going to go to here and say f of x equals 2x plus 1. And then we're going to come back over here. Find g of x. Find g of x if g of x equals 2 parentheses f of x squared minus 1. Okay, so we're over here. I have it written down, much, less neat than a computer writes it, but whatever. And we're trying to find g of x if this is the situation. Now, you might be like, this is crazy, I don't know what's going on, I'm giving up. Just like take a moment and look at it and see what's going on, because it's really like, it's not that crazy. So actually I think I can turn this light on to get rid of that shadow. Yeah, cool. So we see that f of x is really 2x plus 1. And when we see g of x, we see that g of x has an f of x inside of it. But like, that's fine, right? I know if I ever see something and I see it equal above there, I can just substitute. F of x is 2x plus 1. So when I see f of x here, I can just rewrite this as 2 parentheses, instead of f of x, 2x plus 1, 2x plus 1, close parentheses, bring down the square, bring down the minus 1. Squared minus 1. And now, I mean, maybe that's good enough and you're done. But now what we'll do is we'll just kind of simplify this, put it all together. And I think it should come out as a quadratic. But let's do it. So we've got, so let me see. It's 2 times 2x plus 1 squared minus 1. The first thing you have to do is exponents, right? Well, really the first thing you have to do is parentheses, but 2x and 1, they're not like terms, so there's nothing to do in those parentheses. But exponents are going to happen before I go about distributing this. So I'm going to bring the 2 down, and really this exponent means 2x plus 1 times 2x plus 1. So I'm going to do 2x plus 1, and then again 2x plus 1 minus 1. And now we're going to double distribute these guys, and we'll distribute the 2 at the very end. So this guy's going to distribute 2x times 2x, 2x times 1, and then 1 times 2x, 1 times 1. So the 2's coming down again. And in parentheses, I'm going to end up with 2x times 2x is going to be 4x squared. 2x times 1 is going to be plus 2x. There's no minus. There's a difference of perfect squares. So another plus 2x, right? 1 times 2x plus 1 minus 1. Let's finish this up because we're already 4 minutes into this video, and I want to get to the real stuff. So I'm going to now combine these like terms. 2 times 4x squared plus 4x, because I just combined those two, plus 1. Can't put these two together yet because they're separated by a parentheses. Distribute this guy in. 8x squared plus 8x plus 2 minus 1. And we're finishing up by just saying 8x squared plus 8x plus 1. So that's what you got after you go about, simplifying it a bit. Let's get to the actual work for today, which is trinomial factoring. And we're going to try to get through these 2 examples for this video, and then we'll call it at that. Go away. Okay. So when you're doing trinomial factoring, this is not a difference of perfect squares. There's nothing to divide out of each of these. So what you need to do is look at how a factored form would be. So I'm going to say, all right, x squared plus 5x plus 6. X squared plus 5x plus 6. Let's jump to it. There we go. X squared plus 5x plus 6. When this is factored, we've seen in more difference of perfect squares factoring, but factors, very, very often, they look like two parentheses, and then x plus or minus some constant, and x plus or minus some other constant. And you can start to notice a pattern for how the double distribution or the FOIL method here, multiplying binomials, gets me to up there, which is what we're going to use here. So let me get to it. Let's say I had I don't know, x plus I'll say x plus 2 and x plus 3 coincidentally, right? If I do the double distribution here, let's see what happens. X times x, x times 3. This is going to get me x times x is x squared. X times 3 is going to get me plus 3x, right? I'll do the other part of the distribution, right? Whenever you see something like this multiplying, you just take everybody in this set of parentheses, multiply it, distribute it to everybody in there. It's just distribution just a couple times. 2x, 2 times x is 2x, 2 times 3 is 6. Now notice what happens, and this is why I chose these numbers, by the way. It wasn't a coincidence, I lied. When I multiply these last two, the two constants, I end up with 6. So when I have factors, I have these last two constant dudes over there. They're going to, when I do my double distribution, multiply to make the last number in my trinomial. And then here's the part, right? So the last two constants, right? 2 times 3 will get me 6. That's going to be the 6 that we see up there. By the way, if you haven't gotten it yet, 3x plus 2x gets me the 5x. These are the factors. I'm just showing you how to get there. These last two guys, they will always multiply to get that last number. These last two guys will always multiply to get that last number. When you do your double distribution, the x times the x is going to happen. You get your x squared, right? That's where it goes. Then I do x times the last guy on the right side, and then I do the last guy on the left side times an x. So I end up with a x times 3, so the 3x, and x times 2, so the 2x. What ends up happening here, though, and the important part, is that these last two guys, they're going to be like terms in the bottom here, so they're going to add together, which means that here's a little rule that you get to learn, is that when I have a trinomial, the factors, the last term in each of the two different factors, the last terms, are going to multiply to make this one, and then they're going to add to make this one. And that's the observation that we make that we're going to use as a way to reverse this situation. So, ready? We're going to get a new little rule. There's a little diamond that people like to use sometimes. I don't like using it. I just like remember the rule. But okay, it looks like, I think they go like this. Boom, and then boom. So here's your little factoring diamond, and here's how you do it. Ready? You're going to take the very last term, and you're going to put it on the bottom, and this bottom of your diamond is the multiply side. Then you're going to take your middle term, and you're going to put it on the top, and this is your adding side. I did not put signs to these guys. Sorry, my eyelash is stuck in my eye. I didn't put signs to these guys because they're both positive. If you want to put signs, you can. It's a +5 and a +6 as well. But usually I only put the signs if it's a negative, right? And then otherwise I assume that it's positive. And then what you're doing is by using what we just talked about before, and if that confused you, pay attention now because this is the only part that matters, is this diamond, once you draw it, you're saying, all right, I want to find two numbers that I'll fill in the blanks here that multiply to 6 and add up to 5. I'll say that one more time. You find two numbers that multiply to your final term, and then two numbers that add to your middle term. And that's all that trinomial factoring is. So what I would do to do this is I would factor out the bottom one. So the factors of 6 are going to be 1 and 6. 2 works. It's 2 times 3. And then I would get to 3 again, but since I already have it there, I found all the factors of 6. And then you just need to check for each of these pairs of factors, which ones work out to make that number over there. So if I do positive 1 plus 6, that's going to get me 7. It can't be 5. 2 plus 3, though, does get me to 5. So that means my factors must be 2 and 3. And then what you would do at the end is you're going to say, all right, well, I know that means that my factors must be x plus 2. Got that guy. And the other factor would be x plus 3. Got that other guy. That is trinomial factoring. This is a simple version of it. I know I'm already like 11, almost 12 minutes into the video. We're going to do one more example because I spent a lot of time talking. And then we'll pause it here, make a separate practice video for later on. Let's get to it. Next example, I like this example being a negative. That's cool. All right, so example number 2 is x squared minus 7x plus 10. Let's hop to it. Now I'm going to talk less, and we're just going to do the work now. So I'll draw my little diamond out. And the rule for the diamond, why did I make it so tiny? I think, all right, I'm going to make a bigger diamond. This diamond might be bigger than necessary, but it's better to have more space than less. Okay, here's your rule. Ready? To use the diamond method, you're going to find two numbers that multiply to the final term, two numbers that multiply to 10, and then two numbers that add to a negative 7, that add to a negative 7. So I'll get the factors for 10. I'll write that over here. 10, I can do 1 and 10. I can do 2 and 5. 2 and 5. 3 does not multiply nicely to 10. 4 doesn't multiply nicely to 10. And once we get 5 already there, here's all my factors of 10. So I got to play around with 1 and 10 and 2 and 5 to figure out how I could possibly add to make a negative 7. 1 and 10 is never going to work, right? 1 plus 10 is 11. 1 minus 10 is negative 9. Negative 1 plus 10 is 9. And what would I do? Negative 1 and negative 10 is negative 11. It doesn't work out. So it must be the 2 and the 5. But I need to make sure I'm putting the 2 and the 5 and then choosing the right signs to make it work as well. 2 plus 5 makes a positive 7. I wanted a negative 7. 2 times 5 gets me a positive 10, so that's okay. If I tried a negative 2 times a 5, well, negative 2 times positive 5 gets me negative 10. That doesn't work. If I did negative 2 times negative 5, that does get me a positive 10. And if I try negative 2 plus negative 5, that gets me a negative 7. So this is going to be the one that works out, and I will write my factors as x minus 2 and x minus 5. This is it. That is trinomial factoring. Last thing, I know I'm like 13, 14 minutes into the video. We're just going to super quick check this. Ready? I'm going to go super speed. X times negative 5. Negative 2 times x, negative 2 times negative 5. That's going to give me x squared, x times negative 5 minus 5x, negative 2 times x minus 2x, negative 2 times negative 5 is a positive 10. So then I'm left with x squared minus 7x plus 10. This was just the check to make sure that we found the right factors. That would have been the answer for the factored form. Thank you. I'm sorry that we went over by a couple minutes than I would have liked. But yeah, that was the do now. Maybe I just shouldn't do the do nows for these videos, make them separate or something. Yeah, that is an introduction to trinomial factoring. Next lesson, we're just going to practice them a whole bunch. Just rattle one right off of another, see some different examples and how kind of like difficult they can eventually get. Yeah.